So as I was stating that tension will have a component. If we want to incorporate that component of tension, equation will see some change. How? Let us take the magnified image. Over here you got t plus dt, right? And here, if I'm magnifying it for better visibility, here we got t. This angle is d theta. So the angle between t plus dt and t is pi minus d theta, right? This quadrilateral 90 d theta, pi minus d theta. What we get to see is toward the center, force that we are getting is t plus dt. I make some space. Oh, okay, here I can write t plus dt, right? T plus dt, we have the component of it, pi minus d theta divided by 2 if we take. So 90 minus d theta by 2, or whichever way you want to do it, t plus dt and t, they are the two forces, and the angle that we have got is pi minus d theta. So we are resolving it in the direction pi minus d theta by 2, pi minus d theta by 2, that way we can take. What do we get to see then? This, I'm yet again magnifying it, this is pi minus d theta. T plus dt, and this is t. This force is in this direction, this force in this direction, and we want to get the resultant. So resultant from here will see itself coming out to be t plus d theta, this direction, pi minus pi by 2 minus d theta by 2, and t. So when we calculate what is the value of tension, we get it as t plus dt into cos of the angle 90 minus d theta by 2. So cos 90 minus d theta by 2 will be sin d theta by 2, and sin d theta by 2 can simply be written as d theta by 2 because d theta is very small. Cos 90 minus d theta by 2, sin d theta by 2, and that is very small, so d theta by 2. This for this one, and for tension accordingly will be t, same, d theta by 2. We can neglect this, we get from here t d theta. Please be wary of what we are getting. This is what we got, and from here we got to see that it is equal to t d theta. If that is to be incorporated here, then we will write not only normal, but also this was a normal, this normal we will write, and also we will write, now tension, normal taken already, normal being done. There is another component of tension, we took it in this direction, there is another component of tension this way. So normal is up, and that component if it is added, I make the subject over here, that component. So that component if it is to be added, we will mark over here t d theta and then equate it to 0. That is what we'll be doing, t d theta and then equating it to 0. What now? That t d theta, if, oh, and we should, why? Because that part is very much viable now to be taken. T d theta will have an effect. Why t d theta is negative? It being inward. So that has got an effect, and that effect we cannot discount on. See, this is equal to t minus d plus dt minus fs is equal to mass into acceleration, is not going. And I wanted to know what will be normal. We want to know what will be normal. So normal we got equal to how much? Normal we got equal to component of mg and component of tension. So this part one may take, one should take. If that is to be incorporated, we are taking that part. What then we get to see from here? Mu into normal is there, and then you have another component which is t d theta. Please do check t d theta, another component. So d theta will remain. Tension that you are getting, mu into normal, we got d theta term here remains, and here we get the term, this part t minus dt, we got dt, this part mu into normal, this is what we are getting, d theta can be out. Now t d theta and mu naught, that term should come to the left. Or what else we can say is we'll be taking this factor, that is mu naught d theta, to this side only. We'll not take it to the other side. From there, the component which was important for us, this is tension 1, mu into normal also taken, and normal, the other factor that we got was Td theta. Everything is being taken, check the equation and be confirmed on the equation. This is the equation that we are getting. Now what we have to do is, we have to check what happens to tension. How can we make tension the subject? Over here is dt, and over there what you are having is Td theta. And how are we getting Td theta? That is also important for us to understand. We are getting Td theta because we have taken component of tension radially inwards.